All right. Moderately good morning. Yeah, not the best morning today, unfortunately. All right, so I better talk about midterm stuff. What's up, music fan? I'll talk about midterm stuff first. So that sucked. First of all, I'm sorry you all had to go through this. That we shouldn't have issues like this. It's super embarrassing when I'm teaching you how to write code and I have you using something that performs so poorly like that. The app is working. It does work. It's just horribly, horribly slow. We'll look into exactly, uh, why that's happening. Hopefully, we'll be able to get something fixed by the final exam. But the 11 a.m. Midterm, of course, that's still going to be slow. There's no way we're going to fix things by then. Uh, what's up, Leba? Oscar, what's up? So as for solutions, I'm getting flooded with requests. I'm not going to respond to everybody right now. I'm a bit frazzled right now of everything that's happening. Uh, so I'm not going to make any snap decisions right now, but I will say I'll make a decision that's going to be fair for the entire class. Once all the dust settles, we have the 11 a.m. exam with them. I'm telling them in the email that I send out with the links that I'll encourage them. I'm encouraging them to take screenshots and send screenshots to me. Hopefully that goes a little smoother. I believe submission itself was what was slowing things down. And then once so many students were submitting at the same time, then the quizzes started loading really slow. And it just snowballed from there. But I think submissions is the bottleneck. Um, because when we're not like doing the practice quizzes, doing lectures, there's no other slowdown. Even during regular fall and spring semesters, when it's in a lab setting with 20 students, even that we don't experience this issue. So having it was only 37 of you taking the exam, so doubling the number of students was enough to hit some threshold where the app just can't keep up with all the submissions, and it just snowballs and gets slower and slower as it goes, unfortunately. So I'll come up with a solution. The exam's still over at 9:45, so it's still over right now. But I will, once everything settles, once we have the 11 a.m., let's see how that one goes also, and then for the whole class, I'll make decisions. I don't want to speculate as to what those decisions will be, but I'll come up with something that's going to be fair for the whole class. There are ways that I can do this. It looks like a good. Well, I can check right now. I have 33 submissions for DS2. No, I have 37 now. So it looks like the submissions are still coming in. But some of those are going to be partial solutions, as students can't finish in time and it's 9:45 and you click submit. You got a partial solution that's only partial because you had to wait on the app for so long. And it looks like most of y'all did do DS2 last, which is the one I would have done last as well. That's the good strategy. So especially with DS2, I'll take the time the time crunch into account because DS2 got it the worst. But there are things I can do. There are things I can do to make this right. Taking that into account, I think once I have all the data, all the information, I can digest this for a bit. I think we can just solve this on the grading side. For those of you who lost traces entirely, that I think there's a way to recover those from server logs. So that's going to take me, a bit of time and a bit of work, of course. But I think we can get those ones back. So I think I think this is recoverable. I think we can do it. The one thing I can't give back is the extra stress added by waiting in the middle of an exam, wondering if your submission's going to submit. I can't give that back to you. That I apologize you had to go through that. I know how stressful that is in an already stressful environment. And all I can say is that we'll address it on the grading side, that we can. There are things I can do on the grading side to make that fair. As fair as I can, at least. DS2 never even loaded. Yeah, that's never finished loading, and it's still loading. But I submitted. Wait, how do you submit if it's still low? Oh, the submission is still loading. Is that what people meant? I thought. the way it was worded, I thought some people were having trouble actually loading up the trace itself. Like they couldn't even get to the code. Maybe it was just submissions everybody was waiting on. But anyway, I lost a bit of time for this lecture, so let's get this lecture down because I got to get you knowing how to do Programming Task 6. We still got to keep moving forward with the course. Your new goal is Programming Task 6, of course, and my problem, like the midterm is my problem now. I'll figure out some fair way to handle the midterm. But that's in my lap now. Task 6, this is what your focus is. Okay, so task 6, we have 3 different formats of data for songs, including ratings, movies, and then movie ratings, which are CSV files in... if you sent the screenshot... Oh, yeah, I forgot to finish reading that. If you sent the screenshot, that's good. Emailed screenshots, I'll definitely accept all those for this midterm. Both would take a while to load, so it was trouble loading the trace and submitting. Okay. And that's what I thought at first, but so I'll go back to that one. Having trouble loading the trace and submitting. Okay. Yeah, having trouble opening it is the bigger issue. Like, if it's trouble submitting, I can say, well, screenshots, I'll accept screenshots in the email. Once it has trouble loading the code, that's definitely the bigger problem. I still think it was submissions that was the issue, but once the server's busy handling all the submissions very slowly, then it had trouble loading the traces themselves. Yeah, because once it has trouble loading the trace itself, you literally just have to sit there, wasting time on a time-limited environment. That's unacceptable. That's something I have to fix. Before the final exam, but also in grading. That's something I can address during grading. I don't want to speculate as to what the solution is going to look like, but just as a vague statement of what it might look like is I don't have to hold directly to the syllabus the way that AOs are worded, that I can give AOs, even if you didn't get all 4 traces, I could still max out your AOs if it looks like your submission was affected by the loss of time. It's as vague and specific as I can make it. Is 9:46 a.m. late? Considering everything that just happened, no. I will accept that. That is not late. If I was like, I know the app I made you use really crapped out there, but 46 seconds, I'm still being strict. No, I'm not going to be that strict. Even if it's like 5 minutes late, I'll probably still accept it. I'll just assume it was loading for 5 minutes during submission. I will definitely accept that, Jay. So there's 3 different file formats. They're all going to be CSV formats. The songs.csv will be song ID, artist, title, the 3 strings for the song constructor. I'm not going to accept them now, but if it's, there's some reasonable window there where I'm going to accept. I'm not going to accept submissions right now. The reason I can't accept submissions now is because there's a large portion of the class would have submitted partial traces at 9:45. If I say right now, 10 minutes after the fact, like, oh yeah, you can still work on it now, that's not fair to the students who submitted partial solutions at 9:45. So I can't accept now, but like 5 minutes late, I can assume that somebody clicked submit at 9:45 and waited on the app for 5 minutes. So that's the reason I would give definitely a 5-minute buffer in a situation like this. But I can't go further than that because then I can't guarantee that you weren't working past 9:45. If I allow one student to work past 9:45, it's not fair to everybody else. So, but that's part of what I mean by I got to come up with a solution that's fair to everybody for every situation. Like everybody's going to react a little bit different to this situation, and I have to come up with something that's fair to any number of different reactions. So I'll get something that works for everybody. If you refresh the link and submit it, finally submitted, but it's 10 minutes late, I don't know. Send me an email. I got a lot of data to process. Send me an email, and you can all send me an email and tell me your stories, your exact specific stories, and but I gotta get this lecture down. I lost a lot of time for this lecture, so let's get it. Luckily, this is the lecture that I could have put during the midterm because it is shorter. There are things I gotta cut, of course, but we can still get the good bits, the most important things down. So the songs.csv is the 3 things for the constructor, and then a reviewer ID and rating for each rating. The big thing with the songs.csv is you will have duplicate songs in here. So if a song appears more than once in this file, you have to detect that you saw that song more than once and add both of the ratings to the same song object. So we have to find those, and you can do those by ID or title. My titles are unique as well in all my test files. And say, have I seen this song before? If I've seen it before, add this rating to the song object I've already created. If I have not seen this song before, then create a new song object with this rating in it. So that's the big thing with the songs.csv. Movies.csv, this is going to be movie title and then a comma separated list of cast members, any number of cast members, but there's going to be at least one guaranteed. So you can assume that there's at least one cast member. And with this, the movie titles will be unique. There will not be any duplicate movies, any duplicate movie titles in this data. Somebody asked on Piazza. I realized I forgot to put that in the spec here, but there won't be any duplicate movie titles in this file. So you don't have to handle duplicates at all when you're parsing this file. Just don't have any code that handles duplicates. Just read each line as though it is a brand new movie. And then with movie ratings, this is where we will have duplicate movies, movie titles. The movies will all be unique by title. This file is going to have title, reviewer ID, rating. So you have the information you have for each rating. And each time you see this title, you'll add that rating to the movie with that title. And I'll get more specific when we get into the specs. So what you actually have to test and code are 3 methods that read the 3 file formats that we just went over. So read songs. The big thing is duplicate songs, making sure the ratings go in the same song object. The common mistake here is creating a new song object for each line in the file. And then you'll have the same song multiple times for each line that it appears instead of having all of the ratings for that song in one song object. Read movies. There are no duplicates, no duplicate issues here. So go through read movies, and each line is a new movie. And then read movie ratings. This one is a little trickier. You're going to get an array list of movies and the file name for the file you're going to read. And the array list of movies is intended to be the output of read movies. So these are all the movies that you know about. And then the movie ratings file is going to have ratings for the movies that are in this array list. And you'll go through, and each rating, you have to check a few things here, is do I know about this movie? So for each rating, check if it's in this array list of movies from the constructor. If it's not in that array list of movies, then it's a movie that you don't know about. You don't know the cast members for that movie. So you throw away that rating. You completely ignore it. If it is in that array list, then you have to ask the same question you asked with songs. Have I seen this movie before? So do I have a movie object for this movie? If I do, add the rating to that movie object. If I haven't, create a new movie object for that movie and add it to the output array list. And then any movie that's in the input array list that has not been rated at all should not be in the output as well. So we have a few edge cases here. Movies that have been rated that are not in the input array list, those should not appear in the output. And movies that are in the input array list that have not been rated, those should also not be in the output array list. Something only shows up in the output array list if it's in the input array list and has at least one rating in the ratings file. When testing these methods, possibly the hardest part of this method, of this homework, the definitely the new thing that I'm showing you, the new 116 thing that we're doing on this assignment, is that the array lists can be in any order. Because you've read CSV files in 115, we just have to talk about how to do it in Java. That's why today's lecture itself is pretty short. But the new thing is, how do we test an array list that's returned when the array list, the values in the array list can be in any order? That gets not too tricky, but a little trickier. That we do definitely have to think about how to do this. So the utility method walks you through, not walks you through, but asks you to do this for an array list of movies, 2 array lists of movies. Check if they have all the same movies with the same titles and the same cast members, but the array lists can be in any order. So how do you check if an array list has all the same values as another array list, but in any order? Every array list we've checked so far, the order was exactly how we would expect it. There was a defined order. Same with linked lists, and that'll be true for the whole semester. Every linked list that we test, we assume that the order is a very specific order for the values. But now the new twist is the movies can be in any order, and the songs can be in any order. So I do recommend writing a compare song array list method. I don't force you to, just because at this point I feel like I don't have to force you to do every little step of the homework. You can start filling in the gaps. I give the note here that, hey, you probably want to do the same thing for songs, because the same applies to the read songs method. The songs can be in any order. But that's the thing. How do we check 2 array lists if they have the same values but in any order? And whenever you're, so we have to test methods that read files. Whenever you're testing a method that reads files, you need to give it some files to test. And I strongly recommend, I won't have too much time to go through like examples in today's lecture, but I strongly recommend creating smaller data files. So for each one of these files, I give you some sample data, and those files are pretty big. So I recommend creating smaller test files for your test cases, where the first test case might just have 1 line in the file, just straight up 1 line, and then you know very simply what the expected output is, and then start adding more complex test cases with multiple test files. Those test files should go in a directory named data at the root level of your project. So right in the root level of your project, right click on this, do new directory, call it data with all lowercase letters. Make sure this D is lowercase. I had very not sad, but very frustrated students who had a capital D right here and always kept getting errors when they submitted to Autolab. It would be incorrect. Your test failed a correct solution is the error you're going to get if you have the wrong capitalization. Because in Autolab, I'm looking exactly for a directory named lowercase d, lowercase a, lowercase t, lowercase a. It has to be named exactly that. So put all your test files here, and then use those test files in your tests. And when you read them from your tests, the string should be exactly this, assuming you named it movies test1.csv. Okay. So that's task 6, a lot of reading files. Let's do some slides. Reading files in Java. So, quick review of why we even use files. So, everything in our program is in memory. All the information our program uses is in memory, so far at least. Everything we've seen in this semester, every piece of information, every piece of data goes on the stack or the heap. It's all in memory, it's all in RAM. And then when the program ends, all of that data is destroyed. So if we want persistent data, then we have to go over to our disk. We can't go in memory anymore. We have to go over to the disk, to our long-term storage, and save data there. And that's why we use files. Files are going to live longer than the execution of our program. If we write a file with our program, that file lives longer, after our program ends, and we can read files to get data that was saved before our program began. It's persistent storage longer than the life of any one process running on a machine. To do this in Java, this is it. Actually, it's not it. I lied a little bit. But let's break this thing down and talk about how to read files in Java. This is the simplest way to read files in Java. If you've read files in Java before, or if you look up any tutorial on reading files in Java, it will read them using buffered readers pretty much exclusively. It took me a while to find that this method even existed, because it seems like everybody on the internet says, no, buffer your files, which is decent advice, but if your files are small enough, you really don't have to buffer them. We have lots of memory in our machines these days. But it's not a bad idea to buffer them either. So let's break this down. If you don't want to think about what I just said about buffering, don't bother. But if you've seen file I/O and seen the other way of reading files in Java, that's because they're buffering the file instead of reading the entire file into memory all at one time, which is what we're doing here. We're loading the entire contents of the file into one array list using this code. So to do that, first we need to use paths to convert a string into a file path. Java has no way to directly just take a string and read a file like Python does. We have to convert that string that represents a file name into a path. So this paths.get is going to interpret slashes as subdirectories and navigate your file system in that way and generate a path for us. Get is a static method of the paths class. So that's how we get this syntax. We're calling the get static method through the paths class that we imported here. We feed that to files.readAllLines, which will, as you guessed, read all the lines of the file. This takes a path. That's why we had to convert our string to a path first. And this is going to return a I don't have it on screen. I think it's a list. A list of all of the lines of the file. Oh, here it is. That'll return a list of all the lines of the file. We never talked about what a list is. It's actually an interface that is implemented by array lists. It's stuff we'll talk about on Tuesday with inheritance. Maybe not that specifically, depending on what examples I come up with on the fly. I don't think I talk about it in the slides. But it'll return a list. If you don't want to think about what a list is, first of all, if you know what a list is, you want to work with the interface, knock yourself out. I'm not going to stop you. In all the methods for the homework, you do have to eventually return an array list, but you can iterate over a list of the strings. That's perfectly fine. If you don't want to think about that, and you don't want new extra stuff weighing down your brain when you're doing the homework, feed that list into the constructor of the array list class. Create a new array list that will take a list as one of its constructor arguments and create an array list with all the values of that list. This is the same thing we do with arrays.asList that creates a list with all of our values, and then we feed that list into the array list constructor. So with this, we don't have to think about lists. We can just think of an array list like we have all semester. And this array list will contain strings with one string for each line of text in the file. And unlike Python, this will remove the new line characters, the trailing new line character at the end of each line. So we don't have to worry about that with in Java, the way we're reading files like this. And that will read your file, except I did leave out some code. This code doesn't compile. Java won't run this code as written. If I wrote a main method in here and I don't even have my class. I have quite a bit of code missing. But if I added the class and a main method that called read file, Java would not even run my program. And the reason for that is that this is very dangerous code. This is dangerous code because we cannot guarantee that the file exists, the file that we're trying to read. We're taking a string, converting it to a path, and that string might not be a valid path. And there's no way, a valid path to an actual file on disk, and there's no way to guarantee that it will be a valid file. No possible way. There are ways to check. We can say if this file exists, then read it. But, and I don't have time to go through this. I like this example, but I don't have time to go through the whole thing. But the short answer is there can be something that happens in between there. In between your check if the file exists and then reading the file. There has to be some amount of time that elapses there. And in that amount of time that elapses, it's possible that the file could be deleted. Because files are shared with among every process on your machine, there could be another process on the machine that deletes the file at the exact moment right after you checked if it existed. So we can't actually guarantee that this thing exists. We just have to try to open it and see if opening the file works or not. And Java won't let us just try to open the file unless we literally try to open the file. That'll make more sense when we see the code. But let's talk about exceptions, because this will throw in a file IO exception, I believe it is. Throw a file IO exception and crash the program. And we've seen exceptions all semester. Null pointer exception you've seen a lot. Index out of bounds exception a few of you might have seen. Stack Overflow error, not necessarily an exception, it is an error because it will crash the program. But these exceptions can actually be caught. We can check for these exceptions and say, if this exception is thrown, then don't crash the program, but do this other thing instead, whatever you code it to do if that exception is thrown. That's what we want to do here with file IO. And that's what we could do with null pointers. You could catch your null pointer exceptions and not crash the program. It's one way to get rid of the null pointer errors. It's much better to just have your null checks. But in your testing, you could say, if a null pointer exception was thrown, then fail this test instead of crashing and erroring out of the test. That is one solution to get rid of your null pointer exceptions in your tests. It's not advised to do that in your code. You should actually check for null in your code for sure. But any exception that's not caught is going to crash the program. So every exception you've seen so far, unless you've seen what we're about to see before and you have been using it, if you haven't done that, then any exception that's been thrown before will be uncaught and crash your program. So let's see how to not crash the program when an exception is thrown. Because this might throw an exception, but we can handle that. We can say, you know what, that is dangerous code. It's fine. It might throw an exception, but let's just handle that situation. So we're going to add what's called a try-catch block. We're going to try to run the code in the try block. And if during the execution of this code an exception is thrown, we're going to catch that exception. So we're going to say, if an IO exception was thrown while running the code in this block, then run this code instead. So if this file doesn't exist, there's going to be an error converting that string to a path and reading that file. And it's going to throw this exception. And when that happens, the code in the try block will stop running entirely. So you won't get the rest of the code in the try block executing. We won't create a new array list and return it. We won't do any of that stuff. We're going to jump right to the catch block and then run the code in the catch block. So if this file doesn't exist, we're going to return an empty array list. But if the file does exist, we're going to read the lines and return the lines of that array list. And we're catching specific types of exceptions. We can have multiple catch blocks for what it's worth, but that's not something we're going to do in 116. That's nice to know information. So if the file doesn't exist, we run that code, return an empty array list. And we're reading strings that are going to be in CSV format. So we're going to take our lines and split them on commas. And I have to give this note because, I don't know, I got to get rid of this. I think we'll start parsing the proper way, maybe next semester. But we're going to split the lines on commas, which is not the proper way to parse CSV. This is not how we are supposed to parse CSV, but we will get away with it in 116 because I've washed all the data that you're going to use to make sure that this is okay to do. So the problem with splitting on commas is what happens if the data itself contains a comma. If you're splitting on commas, you're going to split a value in half and treat each half as its own value. You're going to have all kinds of errors all over the place. So I made sure every song title, every artist, every movie title, every cast member's name, no commas are going to appear in any of that data. If there is a comma, we would have big issues because we're not parsing CSV the way it's meant to be parsed. If there are commas, the proper way, if there's a comma in the data, you surround that value with double quotes. And then the question is, well, what if there's a comma and a double quote in a piece of data, and then your double quote that's part of the data needs to be escaped with a backslash. So we can represent anything if we add those conditions, but adding that to your homework and saying, look for double quotes, but not double quotes that are escaped with a slash. It's just a lot of extra tedium that doesn't relate to what I want you to get out of 116. I think eventually we'll pull in a library and just have you call a library method that parses CSV, like is built into Python. But we don't have a built-in CSV parser in Java, so we'd have to pull in an external library. Maybe we'll do that someday. Not this summer, that's for sure. So what we're going to do is split on commas. So strings have a non-static method called split that takes another string and will split your string on that value. So if I have the string ABC and I split it on commas, what this returns is an array of strings with the values A, B, and C at indices 0, 1, and 2. So we have 3 values after this split. And if you don't want to think about arrays, similar to my last conversation about lists, if you don't want to think about arrays, well, you can use arrays.asList to convert it to a list, and then stuff it in the ArrayList constructor, and then you don't have to think about arrays at all. But this will return a plain array, an array of strings. If you want to work with your array of strings, go for it. I'm not going to stop you. But if you don't want to think about it, if you're thinking, you know what, array list and hash map, linked lists, trees, and graphs, that's enough data structures for me at the moment. And you don't want to think about lists and arrays, I'm not going to blame you. Just convert that to an array list and work with your array list using the methods that you've used all semester. That'd be perfectly fine. If you do use the plain array, it is the bracket notation, like you saw in Python, to use the plain array. Okay, and there are cases where we need to convert strings into numbers. Here's how to do that. Integer.parseInt is the one you want for your homework. That's going to take a string. As long as that string is well formed, then this is going to give you an int in that string represents. So this will be the value 64 as an int in this example. But if I like spelled out 64 or like FOUR, that's going to give me a malformed string, malformed number exception, I believe it's called. But it'll give you an exception and crash your program unless you catch the exception. We're not in the business of catching those exceptions in 116 though. You can assume all of the rating values. That's the only thing you'll need to convert from strings to numbers is the rating values for songs and movies. And those will all be well-formed ints. I'm not going to give you data that's not well-formed. Don't create any test files with data that's not well-formed. Make sure those are all actual ints. Because you will crash my solution too. My solution doesn't catch those exceptions. Neither should you. You know, in the real world, yes, you would. For our cozy academic environment in 116, let's not worry about it. And I'm not going to do live coding, again, for time constraints, but oh my goodness, what am I looking for? Uncommitted changes, stash. But let's look at some code that's already complete. And there's just one big thing that I want to highlight here, if I can get there. Okay, so this is a method load countries. Actually, I'm going to get through all this stuff. This is a method load countries. So maybe I will talk about the other one too. Load countries is going to take a file name. So here I'm calling the load countries method, And when you're using your file names in your tests, it should be data slash and then the name of the file. And the file should live in this data directory in the root of your project. That's the structure we have set up that Autolab is expecting for testing with files. So in my data directory, I have this cities test 1, which is a very small file. It's just one city. And we have this format: country code, city name, region name, population, latitude, longitude. Oh, I could have just, I was doing that from memory. I could have just read the header line. And then I have a second file with a bit more information. I have multiple cities in the same country, which is the thing I want to highlight right now. And then my test, I'm generating my expected, putting all of my stuff in my expected array list. Same here, my expected array list. I expect this city to map to, or the country to map to all the cities in that country, which is what my code does. I want to read in this CSV file in the format that I just showed and return a hash map that has the country code mapping to every city in that country. And I have a city class. For completeness, let's jump to it real quick, which has all of the values that we would expect for the city from that data file, where location is latitude, longitude, getters, setters, and constructor. And city is these 5 values: getters, setters, actually I only did getters, it looks like, a toString, and a constructor. So nothing fancy with these objects. They're just containers to store the values from my data file. The big thing I want to highlight here is how to get multiple cities into the same country. This is exactly when you read ratings for songs. How do you get multiple ratings into the same song object? That's what this is intended to show you. Same with movies, the movie ratings. When I have a movie that's rated multiple times, how do I handle that? So with this, I'm creating my hash map, an empty hash map that's going to map countries to all the cities in that country. Read all the lines of the file. This read file is the method exactly as we saw in the slides. And we need some way to handle that header line. For your homework, there is no header line, so you don't have to worry about this. But I'm removing the value at index 0 from after reading the file because that's my header line. I want to throw that away because if I try parsing my header line, as soon as I get to parsing the int, and that int is the string population, I'm going to get errors. So I got to get rid of that header line. I'm going to split each line on commas and then extract all the values from that from this array list after splitting on commas. So I'm thinking of the format of my data, which is country. So at index 0, I'm going to have a string for country. City name at index 1 is going to be the name. Region, so index 2 is the region. Population at index 3 is the population, which is an int. So I'm going to convert that to an integer first and create an int for population. Then latitude and longitude in indices 4 and 5, which are doubles. So I'm going to parse them as doubles and store them as doubles. I'm going to create a new location object and a new city object because each line is going to be its own city, so I can safely create the city right away. And then I have the thing we have to ask is, have we seen this country before? So if we haven't ever seen this country before, we have to initialize the country in our hash map, add it to our hash map, and then get this city into the new array list that we create for that country. But if we've seen this country before, then we already have the country in our hash map, and we need to add the city to the existing array list in that hash map. And I'm going to do this in what I think is a pretty clean way to do it, is I'm going to say, have I seen this country before? So I'm going to take the country code. That's going to be the keys to my hash map. I'm going to take that country code that I just read from this line of the file and check my country's hash map and see if it contains that key. So if the country's hash map has a key for this country, that means I've already seen this country before. If it doesn't contain that key, that means I have not seen this country before, and I need to initialize that country. So I'm going to say, if I've never seen this country before, initialize that country. So I'm going to put that country as a key into my hash map with the value of a new empty array list. And this is something we call lazy initialization. We're going to initialize our values at the last possible moment. As soon as we need that value, that's when we're going to initialize it. So now, after this conditional runs, whether this condition was true or false, I actually don't care if it was true or false. I know that after this conditional runs, that country will exist in my hash map. It has to exist. Either it already existed or it was just initialized just now. But either way, I know the country is in my hash map, and I know that it maps to an array list. It's not going to map to null or anything because I initialize it to a new array list if it's my first time seeing it, and I'm never deleting that array list. So I'm going to get that array list for that country. This is going to resolve to a reference to an array list, and I'm going to add this city to that array list. So the correlation to songs, what I recommend with both songs and movies is creating a hash map like this. Create a hash map. Well, I'll talk it through with songs. Create a hash map of string to song, where the strings are the IDs for those songs. String is the ID, and then it maps to the song object. And then you can do the same thing. If my song's hash map doesn't contain a key of the ID of the song that I'm reading for this line of the file, if it doesn't contain the ID, then initialize it. Put the song ID with a new song with title, artist ID, probably not in that order. I don't remember the order off the top of my head. But new song with the 3 strings. And then whether it was initialized, whether you just created that song or not, you're going to go to your hash map, get the song object for that ID, which has to exist, because if it didn't exist, you just initialized it. If it did already exist, then you didn't have to initialize anything, and this was false. But it has to exist. It has to exist if you get to this line of code. So grab that song reference by its ID out of the hash map, and then add the new rating from this line of the file. So that's my recommended solution for that. Same with movies. Hash map makes it easy. A lot of you will use array lists, like the methods for the homework have to return array lists in the end. So a lot of you just hang out in the world of array lists, and that's fine. But your check right here gets a little more complex because you have to iterate over the entire array list to check if there is a song with that ID, and then add to that song with that ID. Hash map makes things a little cleaner. But in the end, when you return, you do have to go through that hash map and return an array list. You do have to return an array list. But if you want to get all the values of a hash map, which it's weird because it's array list of array list here. But if this were songs, like it should be for your homework if you're using this approach, then this would be songs. We'll call it cities. New array list. Hash map. What am I doing? Countries. Values. You can just do that. So if you're using my hash map approach and you need to convert that hash map of string to song to an array list at the end, array list of songs, the songs I'm going to return, new array list, my songs hash map dot values. Simple one-liner to convert the values of a hash map into an array list. And you can even put this on a return line. This will give me an error here because it's not the right type, but you can just return new array list. So converting that hash map values to an array list is not a big deal. And the last thing, I don't really have time to go through it, but and I don't have a one-to-one example because I don't want to give away the whole homework. But for comparing two hash maps where the values can be in any order, I have to check if... doesn't really work for hash maps, does it? I thought I had an example. It's not going to be there. Yeah, I guess I don't have an example. But what you want to do is iterate over. First, check the sizes. If the sizes of your data structures are not the same, that's the first check you should always do when you're comparing two data structures. If the sizes aren't the same, like, you're done. There's nothing else to do. If the sizes are the same, go through your expected songs or movies, and for each expected song, you have to check if it exists in the actual, in what you actually got from the method. And for each one, check if it exists. And if it does, then move on to the next one. But if it doesn't, the test needs to fail right there. So for each value of the expected, iterate over each value of the actual and look for that value in the actual. And once you find it, make sure it has all of the same values. And if it does, then move on to the next one. Which, setting that up, there are tricks to it. It's one of the cases where I actually like to use a Boolean flag. So for each value in the expected, set your flag to false. No, I did not find this yet. And then when you do find it in the actual, set that flag to true. And then at the end of iterating through your actual, assert that that flag is true. Because if that flag's still false, it means you went through the entire actual and didn't find that value from the expected. And you can fail the test right there. But if the sizes are the same and everything expected is found in actual, then you're good. Since we don't have duplicate values specifically. Okay, we're 2 minutes over, but hey, I think that was good timing for losing so much time for this lecture. And that's what you need for Test 6. We did get it. And again, I'll have news on the midterm. I can't guarantee when. Let me get through the 11 a.m. midterm. Hopefully it's not as much of a disaster, but I mean, it probably will be, unfortunately. There's not much I can do at this point, at the last second. But yeah, I'll keep you posted on what happens with that. I don't know if I'll have a decision by tonight. I'll try to make a decision by tonight and send an email to everybody. I'll try. Because I'd like to get a good chunk of the midterms graded before I make a decision, so I can see how much it affected everything. Where and when can we check the result? The results will be both on the tracing tool and posted to Autolab. You'll see the results. As for when, I mean, I want to get them graded as fast as possible, but I can't give a good estimate as to when. My goal will be to finish grading tomorrow, which I think is fair. If I'm asking you all to do homeworks in 2 days, I should be able to get grades out in 2 days. So my goal is tomorrow. Yeah, I kind of have to commit to that, don't I? You should see results tomorrow. Probably tomorrow night. It won't be early tomorrow, but probably tomorrow night. All right. Yeah, midterm didn't go great. Oh, man. Things were going fairly smooth, too, this semester, but there's bound to be some issue at some point. So keep your eye out for news. I'll keep you posted. Take care, everybody.